Yeah, good afternoon, students. And now it is time for us to gear up and digest DBMS. In DBMS, in my last class, I am talking about the selection operation and projection operation. This is what we are discussing in our last class. We commenced relational algebra. Under relational algebra, we discussed about the selection operation and the projection operation. You might have remembered the selection operation is a sigma symbol we used, and the projection operation is the pi symbol we used for the selection and projection operations. Select is used for horizontal fragmentation. In order to have the selected rows, we use the selection operation. Suppose there are 1000 employees. In an employee database, there are 1000 employees. I am interested to see only employees who belongs to department 10. I want to see the details of employees who belongs to department number 10. You can select only those employees with the help of this selection operation. This is nothing but the sigma. Example. In a database, employee database, there are 1000 employees. I want to see only females. The details of female employees. I'm interested to see the details of female employees. Yes, you can see only the details of female employees. You can see the details of only female employees with the help of selection operation. With the help of selection operation, you can filter. I want to see the employees whose salary is greater than 50,000 rupees. Your question is, you are asked to display the employees whose salary is greater than 50,000 rupees. 50,000 rupees. Yes, you can see, you can select only those rows whose salaries are greater than 50,000 with the help of the selection operation. So it is used to select the required rows which are satisfying the given condition. That is the purpose of selection operation. There is another operation called projection operation, which is represented by the pi symbol. This is a projection operation. You can project the required columns. For example, a tuple contains employee number, name, salary, department, gender, HRA, tax, etc. Lot many attributes are there. I am not interested in seeing all the attributes. I am interested in watching only employee names and their salaries. I want to project only names and salaries. I don't want rest of the attributes. If at all you are interested to project the required attributes, we use this symbol. This is nothing but the pi symbol, which is used for projection. And of course, you can go with the mixed fragmentation, that is a horizontal as well as the vertical fragmentation. Horizontal fragmentation is done with the help of selection operation, and the vertical fragmentation, that is attribute fragmentation, can be done with the projection operation. If at all in a query, if you use both horizontal as well as the vertical fragmentation, then we call it as a mixed fragmentation. The combination of projection and selection can be done, which is called as a mixed fragmentation. The mixed fragmentation can be done with a combination of the selection and projection operators. So this is what we discussed in our last class. Let us have a discussion of today's class, and the outcomes of the today's class should be set operations, union operation, intersection operation, set difference, and the combination of various operations, of course cross product and rename operations. So today's outcome of the discussion's outcome should be set operations, union operation, intersection operation, intersection operation, union operation, set operation, difference operation, and the combination of all these operators, of course cross product and rename operations. So today's outcome should be this. So we will commence the discussion. Let us commence the discussion. Set operations. In your 9th class or 10th class, you might have studied about these set operations, that is intersection operation, union, set difference. All these you might have studied somewhere in your 9th class or 10th class. The same concept is being repeated, the mathematical concepts, relational algebra is being repeated with the DBMS, database management system. The following standard operations, on sets are also available in relational algebra. That is union operation, intersection operation, difference operation, cross product operation, and of course there is another row which is a rename operation. Row, this is the symbol which is a rename operation. A union is represented by U. Union is represented by U or union S. R is one relation, S is a relation. R is a relation, S is a relation. So R union S returns a relation instance contains all tuples that occur in either relation instance R or in the relation S or in both, eliminating duplicates. That is, the data of R, the data of S, both clubbed together you will get output, eliminating duplicates. If there are any duplicate values, the duplicates are eliminated and you will get the data. Once again, R contains some tuples and S contains some tuples. R contains some tuples, S contains some tuples. R union S. R union S. That is the tuples of R as well as tuples of S. It combines the tuples of R and the tuples of S. You get the complete data. Tuples of R as well as the tuples of S. You get the complete data. If there are any duplicates, the duplicates are eliminated. That is a union operation. R and S must be union compatible. That is, union compatible is nothing but you are having the same number of fields. If R contains 10 fields, S also should contain 10 fields. If R contains 10 fields, S also should contain 10 fields. If the first field is integer, S first field also should be integer. If R's second field is character, S second field also should be character. That is a compatibility. There should be a union compatible. The same number of rows should exist in both the relations. First point. The same order of columns should exist. That is the second point. Third point, data type compatibility should be there. Data type compatibility in the sense, in R, if the first column is integer column, in S also the first column should be integer. In R, second column is character. In S also the second column should be character. So it should be union compatible. That is called union compatibility. Unless and until there is union compatibility, you can't union the rows of R as well as S. We will study this with some examples. It gives more clarity. We will study with the example. Now you observe this carefully. Yes, S1 union S2. Let me say this is S1. This is S1. S1 contains 22, Dustin, rating is 7 and age is 45 years. 31 Lubber, the name of the sailor. These are the sailors who drives the boats. 31 Lubber and rating is 8 and age is 55.5. 58 Rusty, his rating is 10 and it is 35.0. This is the data of S1. Similarly, you are having the data of S2, sailors S2. Coming to the data of S2, sailors S2, 28 UP, 31 Lubber, 44 Guppy, 58 Rusty. This is the data of S2. Now you are having the data of S1 as well as S2. When you union this, you observe here, the first parameter is the number of columns of first should be number of columns of second. 1, 2, 3, 4. Here you are having 4 columns. Here also there should be 4 columns. That is the first point. Then only you can union. The second point, the first one is numeric one. Here also first one is numeric. The second one is character. The second one is character. The third one is numeric. Here also the third one numeric. The fourth one is real type, and here also the fourth one is real type. That is union compatible. Now when you union S1 and S2, you get the rows of first relation and rows of second relation, and duplicates are eliminated. Eliminating duplicates. You observe here 22 Dustin. You got 22 Dustin. 31 Lubber. You got 31 Lubber. 58 Rusty. 58 Rusty. 28 UP. You got 28 UP. 31 lubber. Already 31 lubber. We already got the data 31 lubber. And hence you will not get again. 44 guppy. So you got 44 guppy. 58 rusty. 58 rusty is already there. Leave it off. So S1 union S2 is nothing but the rows of first relation and rows of second relation, eliminating duplicates. The rows of first relation plus the rows of second relation, the rows of first relation and the rows of second relation, eliminating duplicates. By eliminating duplicates, you will get the resultant query. Once you study these two tables, S1 table, S2 relation, S1 relation and union, what is the result? Just a minute, you please go through this. Also you can S1 union S2 union S3. You can extend this. I am just demonstrating with only two relations. You can extend S1 union S2 union S3 and so on. You can go ahead. So this is nothing but union operation. Now let us go ahead with the next concept. You observe this is intersection. Intersection. Only the common values will be listed out. Only the common values will be listed out. In this case, you observe here, you are having S1 intersection S2. The common elements are being listed out. S2 is Dustin. In S1, you are having Dustin. This is S1. This is S2 relation. In S1 relation, you are having Dustin, Lubber and Rusty. In S2 relation, you are having UP, Lubber, Guppy and Rusty. This is the data available. S1, you are having Dustin, Lubber and Rusty. S2, you are having UP, Lubber, Guppy and Rusty. This is the data, intersection. We are using intersection. Only the common values will be listed out. If you observe here, Rusty and Rusty, these are the common values. Lubber and Lubber is a common value. That's all. So in result, you can observe, in result only the common values will be resultant. That is 31 Lubber and 58 Rusty. 31 Lubber and 58 Rusty. The common elements will be listed out with the help of intersection. Yeah, please go through.
Sir?
Yeah.
Sir, if 58 is up and 31 is down, what will the output be, sir?
Nothing. Don't get worried about up and down order. Please don't bother about order. So in SQL, you're having a concept called order by, with which you can arrange in ascending or descending order. For time being, you please don't get worried about order. Right? Even order is not maintained, you will get the output. Right? If 58 is at top, 31 is at bottom, no problem. Output you will get 31 and 58, both. Okay, you came to know about union operation and intersection operation. Union and intersection operation. Now let us go ahead with the set difference. Set difference. I want to find the difference of set 1 and set 2. So R minus S, that is a minus symbol. We are using R minus 1. R minus S returns a relation instance containing all tuples that occur in R but not in S. All tuples that occur in R but not in S. The relation R and S must be union compatible and the schema of the result is defined to be identical to the schema of R. What does it mean? The first point is it should be union compatible. Union compatible means number of columns of the first relation should be equals to the number of columns of second relation. That is the first point. And the data types of the corresponding columns should be same. If it is integer, here also they should be integer. The second is character, here also the character, and so on. That is called union compatible. And the third point, after having a union compatibility, if I go with the difference operation, difference operator is represented by minus symbol. Set difference is represented by minus symbol. Now you observe here, the elements which are available in the first set but not in second set will be resulted. The elements which are available in the first set, but the elements, the tuples should not be in the second set. Only those tuples are resultant. Dustin, 22 Dustin. Do you have 22 dust in here? In S2, do you have 22 dust in? You don't have. Dust in, 22 dust in. It is in the first relation. Do you have this in the second relation, 22 dust in? You don't have. When you don't have your output, you will have dust in. In output, you will be having dust in. Again, lubber, 31 lubber. Do you have 31 lubber? Yes. If available in the second relation, you will not get as output. 58 rusty. Do you have 58 rusty? Yes, it is available. And hence you will not get output. Only those tuples which are available in the first relation but not in second relation will be resulted. And hence in this example you got dusty. Dustin 22 Dustin is only in the first relation. This Dustin is not in second relation and hence now why you are not getting lubber? Lubber is in first relation, lubber is in second relation also and hence you will not get. Why you are not getting rusty? Rusty is in first relation, rusty is also in second relation and hence you will not get it. And hence in your output you will get only Dustin. Output will be only Dustin. Right? That is called set difference. The tuples which are available in the first relation but not in second relation will be listed out. Yeah, please go through for a minute and ask me doubts. We proceed to the next concept. You witnessed what is union, what is intersection, what is minus, set difference. Now with set operations, let us evaluate, let us work out with some queries. Let me say this is a table called sales 1, this is table sales 2. Observe carefully. We will work out with the set operations, some exercise programs. The rest of the class we are going to work out with some exercise programs. Let me say this is a table called sales 1. This is a table called sales 2. In sales 1 you are having Vasu, Gopi, Padma, Radha, Giri, Kumar, Vani, Rani, Ganesh and Lata. So there are 10 employees, 101 to 110. There are 10 employees. Male, male, female, female, male, male, female, female and so on. And these employees belongs to north area, south area and east area. These employees belonging to north area. You can observe here some employees belongs to north area, some employees belongs to south area and some employees belongs to east area. And gender you can observe there are male employees as well as female employees are there. And sales amounts. These are the sales amounts which are done by these salespersons. There are two relations, sales 1 and sales 2. Sales 2 contains Vasu, Padma, Giri, Vani and Vittal. And of course you observe here 111 Vittal is not available here. In sales 1 you don't have 111 Vittal. So some tuples are there in this relation, some other tuples are there in this relation. Here you are having 102. Do you have 102 here? You don't have. Here you are having 104. Do you have 104 here? You don't have. Here you are having 111. Here you are having 111. Do you have 111 here? You don't have. So there are some tuples here, there are some tuples here. List out all salespersons from sales 1 and sales 2. Your question is list out all salespersons from sales 1 and sales 2. From this table as well as this table, you are asked to list out all salespersons. So I am using union operation. Sales 1, union, sales 2. Observe carefully what I am doing. Sales 1, union, sales 2. Then in result, sales 1, union, sales 2. Then in result, you will get the details of S1 as well as S2. You observe here, you got 101 to 110 and also you got 111, Vittal. 101 and 101. So you got 101. You got 101. 102 is here, but you don't have 102, but this is union operation. Union operations are nothing but the rows of first and rows of second, eliminating duplicates. And hence you got 102. Here you don't have 102, even then you got 102 here. Here you are having 103 and 103. Duplicates are eliminated and you will get only 103. 104, here you are having 104, you don't have. Here you are having 104. You got 104. 105, coming to the 105, here you are having 105 as well as here you are having duplicates. Only one 105, you will get only one 105. Similarly, 106, 107, 108, 109, 110, and here you are having 111. Here you are having 111, and hence you will get the data of 111. You got output data of 111. So this is union. The question is, from sales 1 and sales 2, list out all salespersons. All salespersons from sales 1 as well as sales 2. So I am doing union operation. Combination of S1 union S2. Dear students, you need to take a book and pen. You need to scribble these queries. Only practice. Only practice. You get acquainted with the queries. S1 union S2. S1, that is a sales 1 union sales 2. The resultant sales 1 union sales 2, you will get the complete stuff. The complete stuff, you will get the complete stuff, that is 101 to 110, and also you will get 111. 111. Let us go ahead with the next query. Your next query. List out common salesperson from sales 1 and sales 2. I want the common salespersons who are available in sales 1 as well as in sales 2. Common salespersons. List out the common salespersons from sales 1 as well as sales 2. I am using intersection. Sales 1 intersection sales 2. The common salespersons are 101 Vasu, 103 Padma, 105 Giri, 107 Vani, and that's all. 107 Vani. We are not getting 111 Vittal. Reason 111 Vittal is only in sales 2, is not available in sales 1, and hence you are not getting. Output is 101, 103, 105, and 107. So list out common salespersons from sales 1 and sales 2. That is intersection operation. Previously we went with union operation. Now we are going ahead with intersection operation. Just 1 minute, you please go through these tables, resultant tables and query. I am proceeding to the next concept. Hope you don't have any doubts. Intersection means the common values. Let us go ahead with this query. Your query is list out salesman names and sales amounts. Salesman names and salesman amounts. I want only two columns. Salesman names and amounts means projection. I need to go with the projection operation. List out salesman name and sales amount from salespersons of East area from both the tables. East area, who are working in East area from both the tables. From both the tables. You observe here I am saying S1 union S2. S1 union S2. You observe here S1 union S2 means both got clubbed. S1 and S2 both got clubbed. When I say union, duplicates are eliminated. From that clubbed form, I am selecting area equals to east. I am picking up only area equals to east and their names and sales amounts. Here you will not get all these salesman numbers. You will not get this. You will not get gender. You will not get gender. You will not get area. Then what you will get? You are projecting name and sales amount. So you will get names and you will get sales amounts. Of whom you are selecting area equals to east, and hence you will get the details of only eastern salespersons. Eastern salespersons are nothing but Ganesh because he belongs to east, Lata because she belongs to east, Vittal belongs to east. So you will get only this portion, your output. Coming to your output, you will get this portion and this portion because that is a projection operation. Only the data will be projected. The data which is projected is salesman name and sales amount. Salesman name is Ganesh, sales amount is 70,000. Lata 35,000. Vittal 70,000. This data only will be projected. All this data will not be projected. All this data is wrong. Only this portion of data, that is Ganesh 7,000, Lata 35,000, Vittal 70,000. Only this data is projected. You observe here, select names and sales amounts. He is asking you to select name and sales amount from salespersons of east area. So all eastern area salesperson names and sales amount he is asking from both the tables. And hence I am using union operation S1 union S2. I am clubbing these two, and from the resultant rows I am picking up only area equals to east. And from that I am projecting only names and sales amounts. This is what I am doing. Yeah, please go through. Right, let us go through the next query. With the expectation that you are following, I am going with the next query. Set operations. Now you understand the query. Your query is list out names and sales amounts of East males. They belong to East as well as males from both the tables. So there is a table called sales 1, there is a table called sales 2. From both the tables, I want to pick up only rows of list out names and sales amounts. Names and sales amounts of East male. They should belong to East and they should be male. They should belong to East and they should be male. East male. East male. So sales amounts of East male students. Names, I want names and sales amounts of East males from both the tables. When they say both the tables, I am clubbing these two tables with union. Sales 1, union, sales 2. Sales 1, union, sales 2. So you will get all the rows as of sales 1 as well as sale 2. Union, from that union, I am projecting area equals to, I am selecting area equals to East and gender equals to M. Area equals to East. They should belong to Eastern area. And gender, end operator. I am using end operator. You observe here, end operator, or operator, not operator, all sorts of relational operators can be used. So area equals to select area equals to East and gender equals to male. East males from both the tables. Yes, sales 1, union, sales 2 from both the tables. And I am projecting only names and sales amounts. I want only names and sales amounts, and hence in the result you will not get salesman number, you will not get gender, you will not get gender, you will not get area, you get only the names and sales amounts of whom? East males. East males are nothing but Ganesh and Vittal. You can see East males, East males are Vittal. East males, here you observe here, this is East female. East males are nothing but Ganesh. East male is nothing but Ganesh. You will get the details of only the names and sales amount. Why you are not getting this? Because I am not projecting. I am not projecting the salesman number. I am not projecting the gender. I am not interested about the gender. I am not interested in area. I am saying East males names and sales amount I asked to project, and hence only the salesman name and sales amounts, only these two columns are projected. Names and sales amounts are projected. You can go through the query, you can go through the question, the corresponding query, and this is the output. This is the output. Just a minute, you please go through. Here, the point you need to appreciate is slowly I'm mingling all the concepts. I'm using set operation union. I'm using the relational operators greater than, less than, or equal to, not equal to, all these I'm using. Logical operators, and or not operator. I'm using selection operation. I'm using projection operation. Slowly in the queries, if you observe, there is a projection operation, there is a selection operation, there are relational operators, there are logical operators, and there are set operations. Set operations. Different operators I'm clubbing while framing the queries. Let us go ahead with the next concept. Your question is very simple. List out only the salespersons present only in the sales 2 table. Sales 2 table. The salespersons who are available only in sales 2 table I want. I want list out the salespersons present only in sales 2 table. Only in sales 2 table. I want those salespersons. So if that is the case, Sales 2 minus sales 1, subtract. The rows which are available in the first table but not available in the second table will be resulted. The rows which are available in the first table but not available in the second table will be resulted. And hence in this example you are getting only Vittal, because Vittal is the only person. 101 he is available there. 101 is available in both the tables. 103 is available in both the tables. 105 is available in both the tables. 107 is available in both the tables. 111 is available only in sales 2 but not in sales 1. And hence in your output, if you see the output, you are getting the output of 111. You are getting the output of 111, Vittal, Mail, East, and 70,000 is the sales amount. That is difference, set difference. Set difference in the sense the rows which are available in the first table but not in second table will be resulted. That's what happening. This is nothing but set difference. Set difference. You observe this. Here there is one question. The question is, list out names and sales amounts of females except those females whose sales amount is greater than 80,000. I want names and sales amounts of females from both the tables. But I don't want the females whose sales amount is greater than 80,000. Listen carefully. I want names and sales amounts. I don't want salesman number. Wrong. I don't want gender. I don't want area. What you require, what you want to project? Name and sales amount. So names and sales amounts. You want to project only names and sales amounts. So rest I don't want. I don't want salesman number. Don't want gender. Don't want area. I want only names and sales amounts. Names and sales amount. I want only these two, names and sales amounts. Here in question, he is not asking the details of all females. He is asking all the females except whose sales amount is greater than 80,000. Whose sales amount is greater than 80,000 means I don't want those females. Now, this can be done in different ways. In different ways you can do this. You can do this in different ways. Sales 1 union sales 2. When I use sales 1 union sales 2, you will get the complete data. Complete data of sales 1 and sales 2. From this data, I am selecting gender equals to female and sales amount less than 80,000. I am selecting only females with sales amount less than 80,000. First, I performed union operation. Sales 1, sales 2. All rows got clubbed up. From all rows of both the tables, I am selecting only females with sales amount less than 80,000. And from that, I am projecting only names and sales amount. I am projecting only names and sales amounts. And hence, you will get only columns of names. You get the columns of names and columns of sales amount. Padma 30,000, Radha 75,000, Rani 65,000, Lata 35,000. You observe here, these are all the females whose sales amount is not greater than 80,000. Padma is 30,000, which is less than 80,000. Radha is 75,000, which is less than 80,000. Rani is 65,000, less than 80,000. Lata 35,000, which is less than 80,000. Here, what I'm doing, I'm performing union operation of sales 1, sales 2. Now all rows, from all rows I'm filtering gender equals to female and sales amount less than 80,000. From those rows I'm projecting only names and sales amounts. That's what I'm projecting. This can also be done in a different style. This is the best way, but also can be done in a different style. I am performing union operation. Sales 1 union sales 2. After performing union operation, you observe this portion. You observe only this portion. After performing union operation of sales 1, sales 2, I am selecting gender equals to female and the sales amount greater than 80,000. So here I am taking all the salespersons whose sales amount is greater than 80,000 and these salespersons are being subtracted. You observe here, I am subtracting, minus, difference. Here you will get all females with sales amount greater than 80,000. These females I am subtracting from rest of the females. Gender equals to female. From rest of all females I am subtracting, I am removing the females whose sales amount is greater than 80,000. So you will get names and sales amounts. You are getting names and sales amounts of only those females whose sales amount is less than 80,000. You can do either this way or this way. Both are right. You can do either the first way or in the second way. You can do both are right. Both are right. This is right. This is also right. Just a minute. You please go through. Right, students. I am proceeding. A query can be evaluated either by using set operations or without using set operations. Either by using set operations or without using set operations, you can perform. You can perform the query either by using set operations or without using set operations, you can perform. Both are right. There is a concept of cross product. Just we roll on this, there is a concept called cross product. Cross product. Cross product. Coming to the cross product, suppose this is one relation, S1 is one relation, R1 is another relation, S1 is one relation, R1 is another relation. When I say S1 into R1, this is called cross product. When I say S1 into R1, S1 into R1, S1 into R1, when I say S1 into R1, listen carefully. Each row of first tuple of first relation, each row of first relation will be connected with all rows of second relation. Each row of first relation gets connected with all rows of second relation. Means Dustin gets connected to 2258. Dustin got connected with 2258. You observe here, Dustin got connected to 2258. The first point is when you use cross product, the number of columns will be the combination of columns of relation 1 and relation 2. 1, 2, 3, 4. Here you are having 4 columns. Here you are having 1, 2, 3 columns. 3 columns. So in result totally you will be having 7 columns. 4 plus 3. 1, 2, 3, 4, 5, 6, 7. Totally 7 columns. Here you are having 4 columns. Here you are having 3 columns. In the result 4 plus 3, totally you will be getting 7 columns. That's the first point. The second point, each row of first relation gets connected with all rows of second relation. Dustin gets connected with 2258. Lubber gets connected with 2258. Rusty gets connected with 2258. I am repeating. Dustin gets connected with 2258. Lubber gets connected with 2258. Rusty row gets connected with 22 and 58, and hence total number of rows will be 6. The total number of rows will be 6 rows. Here you are having 3 rows, here 2, 3 into 2, that is 6 rows. You observe here Dustin 22. Dustin got connected with 22. The Dustin got connected, this first row got connected with 20. Dustin got connected with 58. Dustin got connected with 58. Here the story of Dustin is completed. Now the Lubber got connected with 22, Lubber got connected with 58. The Lubber got connected with 22, Lubber got connected with 58. Here the story of Lubber is completed. Rusty got connected with 22, Rusty got connected with 58. Rusty with 22, Rusty with 58. And totally 3 into 2, that is 6. Totally 6 rows you got it. This is called cross product. This entire row gets connected with this entire row. This entire row gets connected with this entire row. Similarly, the second row gets connected with first row, second row gets connected with second row. The third row gets connected with first row, third row gets connected with second row. This is the thing. I hope this is clear. This is called cross product, or sometimes we call it as a Cartesian product. A cross product or Cartesian product. This concept is called as a cross product or Cartesian product. Important. Just 1 minute. You look into these two tables. All of you, just a minute. You please look into these two tables. This is first table, second table. This is the resultant table. What happened? You just have a glance for a minute. I'm just proceeding to the next concept. We came to know what is cross product. We listened about union, intersection, difference, cross product. Now let us go with the renaming. Rename is represented by a row operation. This is a symbol of row. Rename. There is a symbol of row. This is a rename symbol. Just I am writing P. In fact, this is the symbol. I should use the symbol P. This is the symbol. There is a symbol for renaming operation. For example, there is a table called staff. There is a relation called staff. Listen carefully. There is a relation called staff. I am not interested in that name. I want to change that name as employee. I want to change that name as employee. Then you should say rename employee. I should give the new name. It is an employee. Rename employee. Rename employee. And what is the old name? It is staff. So I am using staff. Employee and staff. Right? And you close it. Now what happens? The meaning of this is the staff table is renamed as employee. The meaning of this statement is the staff table is renamed as employee. Now the new name is employee, no more staff. It got renamed. The name got changed. Similarly, I want to change the staff name as employee and a column name salary as a pay. Already there is a column called salary. I want to rename the column also. I want to rename the column name as pay. Yeah, you can do that. This is a row. The employee means the staff table is renamed as employee. Now the staff table is renamed as employee. And in that employee, there is a column called salary. There is a column called salary. The salary column is renamed as pay. It is being renamed as pay. That's the meaning of rename. It is represented by the row symbol. This is a symbol for renaming. This is a symbol for renaming. That is symbol for rename. I hope you are following what is the purpose of rename. So dear students, in this class, we came to know about the set operations. We came to know what is union operation. That is the tuples of first relation and second relation, eliminating duplicates. That is union. Intersection operation. The common tuples of the first relation and second relation will be resulted. Difference operation. The tuples which are available only in the first relation but not in second relation. That is nothing but the difference operation. And we worked out with the combination of operations, union, intersection, difference and all that, combinations, selection and projection, the combination of operations. We came to know what is a cross product. As per the cross product, each tuple of first relation gets connected with all tuples of second relation. Each tuple of first relation gets connected with all tuples of second relation. That is nothing but the cross product operation. And there is a renaming operation. You can change the name of the table, that is the relation. You can even change the name of a field. You can change the name of a field. You can change the name of a relation for which the rename operation is used, which is represented by the row symbol. This is the symbol of rename operation. Union operation we represented by U. Intersection operation, this is the symbol of intersection operation. Difference operation is represented by minus. And the cross product operation is represented by multiplication symbol. This is the cross product operation. So this is what in this class we discussed about the set operations. Dear students, you have a verification of set operations. You please have the verification of the set operations and rest of the concepts we discuss in the next class. Have a wonderful day. Enjoy the subject and enjoy the day and climate. My dear students, bye-bye.